If you want to step into the exciting world of drone programming and learn how these smart devices can fly, carry out missions, or even influence the battlefield, this video is for you. We'll explore drone programming and dive into the technologies that shape the future. So join me as we enter this world full of code and technology. In today's world, drone programming has become one of the most fascinating and important fields. Drones, also known as UAVs, unmanned aerial vehicles, use advanced technologies to fly autonomously and carry out various missions. For a drone to fly intelligently and autonomously, it requires precise and specialized programming. Drone programming typically involves coding for systems such as flight control, sensors, navigation, and environmental interaction. This type of programming includes working with languages like C++, Python, and even hardware-specific languages like Arduino. The simpler model of these drones, known as quadcopters, has a fascinating and intricate system. To maintain flight stability, this aerial device continuously processes data and environmental inputs through its onboard program, making real-time decisions. When the drone's propellers start spinning, a force known as torque is applied to the body, creating a challenge that causes the drone to spin around itself. To counter this issue, the propellers are arranged in a cross pattern and rotate in opposite directions. This configuration ensures stability, making 4 rotating propellers the optimal choice for this type of drone. So, we now understand the philosophy behind the tail in helicopters. Due to the torque force applied from the main rotor to the body, a tail with a small rotor is added to counteract rotational force and maintain stability during flight. If we want to simulate a bird's flight using code, we can write it using Python modules like this. This code essentially places the drone in a guided mode, raises it to a specified altitude, and then lands it after a few seconds, making it a great starting point. By using the relevant module and geographic coordinates, we can input a list of desired waypoints into the navigation system. These points also include altitude. Keep in mind that a complete system is a combination of all these codes. If our drone is designed for surveillance or reconnaissance, we can use this code for image processing, allowing the drone's camera to recognize faces. In remote-controlled drones, this system is used to report the drone's coordinates to a server, which is updated in real time. Here, we assume the server is hypothetical. After sending the data, the control system detects the drone's status. In military systems, all transmitted and received information is encrypted to prevent the drone from being taken over. You've probably seen a quadcopter drift due to wind or an external force. When this happens, the processor calculates the deviation angle in real time to correct the flight path. Essentially, a differential equation is formed at each moment, determining how much to increase the speed of the opposite propellers to restore balance. On the other hand, programming combat drones is a more complex level compared to commercial and recreational drones. Combat drones are not only used for reconnaissance and surveillance missions, but also have offensive capabilities, such as missile strikes and suicide attacks. These drones typically feature advanced systems for targeting and autonomous decision-making during warfare. Programming for such drones must be precisely aligned with security and strategic requirements. For example, suicide drones, designed for precise strikes on sensitive targets, require advanced algorithms for target identification, situational assessment, and attack path planning. Additionally, reconnaissance drones in combat zones must have highly accurate image processing and AI simulation capabilities to identify targets in complex conditions. Missile-launching drones, on the other hand, demand precise programming to control missile deployment and ensure accurate targeting and destruction of the intended target. Overall, programming these drones presents a major challenge for developers and engineers due to the intricate security and strategic complexities involved.